Hi, and welcome back. Prior to understanding HDFS, it's important that we understand Hadoop 1.x and Hadoop 2.x and the difference between them. Hadoop 2.x also provides a distributed storage system called HDFS and distributed computation engine called MapReduce to solve big data problems. The HDFS daemons are same as in Hadoop 1.x, but job tracker and task tracker replaced by resource manager and node manager. This change was introduced to overcome the issues which Hadoop 1.x had. Now let's understand how HDFS Hadoop 2.x is different from the one in HDFS 1.x. So in Hadoop 1.x, there was no concept of partial namespace availability. If the name node went offline for whatever reason, then the entire cluster was also offline. In Hadoop 2.x, a new feature was introduced called HDFS Federation, which helps in partial namespace availability. We'll see this concept in detail later in this module. Now, as you know, in Hadoop 1.x, the name node was a single point of failure, which means if your name node daemon is down somehow, you don't have access to your Hadoop cluster thereafter. Hadoop 2.x solves this problem by introducing high availability architecture. Hadoop 2.x, the non-HA mode, has same name node and secondary name node working as in Hadoop 1.x. Now, coming to MapReduce in Hadoop 2.x, it replaces old daemon processes of job tracker and task tracker with yarn components that are resource manager and node manager respectively. These two components are responsible for executing distributed data computation jobs in Hadoop 2. Let's very briefly talk about these two daemons. Beginning with the resource manager, this process runs on master node and it may run on the same machine as the name node for smaller clusters. It's responsible for getting the job submitted from the client and schedule it on the cluster, monitoring running jobs on the cluster, and allocating proper resources on the slave node. It also communicates with the node manager daemon process on the slave node to track the resource utilization, and it uses two other processes named application manager and scheduler for MapReduce tasks and resource management. Now coming to the node manager, this daemon process runs on slave nodes, normally on HDFS data node machines. It is responsible for coordinating with the resource manager for task scheduling and tracking the resource utilization on the slave node. It also reports the resource utilization back to the resource manager. It uses other daemon processes like application master and container for MapReduce task scheduling and execution on the slave node. When we put it all together, this is how the architecture looks like. In this architecture, we see that the name node is not a single point of failure. Here we have the standby name node, which is there to take up the role and responsibility of the active name node in case of any failure, and this happens without even the users knowing about it. This architecture is more resilient and is highly available due to the presence of an active name node and the standby name node. In the coming lectures, we will be learning all the terminologies that we've seen here in a lot of detail. So I hope you've understood the difference between Hadoop 2.x and Hadoop 1.x. In the next video, we will see all about HDFS. Thank you.